Okay, good morning. Today we will start with reading how to read the T table. Okay, you can see in chapter, this is from chapter 4, the slide. There's a last two slide which we haven't gone through. So let us see at T distribution here. Here T alpha the notation for T distribution is T alpha. This is known as nu. Okay, you can you can call that as V if you want, but the proper word is nu. This one is the notation we use for mean is mu. Okay, so just some notation. So I will call this as nu. Okay. Alpha is known as level of significance. And this one is known as degree of freedom. Okay, some parameter for you to find T. So let us look at the first question. A. T 0.059 T 0.059 5 and 9. So you can see here 0.05 is here, alpha is here, and the nu is 9. So this is the answer. Let me make it big a bit. So the answer is 1.833. B. Your B is 0.01, alpha is here, and nu is 20. So the answer is this one. For C, the significant level is 0.1, 0, 15. The level of significance is here, 0.1, 15 is here. This is your answer, which is 1.341. And D, zero point 0.025, 14, 0.025 is here, 14 is here, and your answer is this one. Okay, this is how you read a T table. Now we will use T table to do our chapter 5. We will also use Z table. First we will use Z table and then we will use a T table. Okay, that is regarding T table. Now let us move on to chapter 5. Now I'm going to go on with chapter 5. Chapter 5. In chapter 5 we need to know certain notation. Chapter 5 is estimation. Okay, so basically, to cut short certain things, to teach you quite fast, I'm going to I'm going to skip the first slide. Point estimation, no need to learn. Interval estimation, when I go through some example, I will tell you what is that. Now for us to do chapter 5, let us look at example 2. And before example 2, estimations. Now let's say you are given a population. For example, let's say I'm considering those who are learn statistics for management. So my aim is, I'm looking for the students. Let's say I'm looking for students who is learning statistics for management. Now if I consider each and every student in the world who are learning statistics for management, okay, let's say I just put around here, if I consider each and every student who are learning statistics for management, they are inside here in the world, that is known as population. Population is each and every, if you consider each and every student who are learning statistics for management in the world. Okay, so I just shade here. If I consider all the population, let's say this is the population. Guys, just give me a moment. I'll be back. Just give me a moment. Okay, if we consider all the population who are learning statistics for management, that is a population, and the mean population, you will denote it by mu. Standard deviation of population, you will denote it by sigma. Median, you will denote it by, I forgot the name of the notation, but it's like n. And there's a mode. I don't know what is the notation for mode, but there's some notation here for mode. For mode, I don't think so. There's a standard notation. Let's say I put it as S. Okay, maybe I put as M first. M is something similar to mu, so let me put it T, something like that. Okay, this is known as, this one is known as parameter. Parameter. Now, if the same thing, I want to study student who are learning statistics for management, but I'm not considering the whole population. I just consider my class, which is a small portion of the world. Okay, my class have 120 students. In that case, the mean for my class, the small portion, is known as X bar. Standard deviation known as S. Median known as M. And mode, you can put any value if you want. Okay, maybe we can put V, and this is known as sample. Sample is part of population. This is known as, if this is if the variables, all these variables, mean, standard deviation, median, mode, is parameter for the population, then for mode, I suppose mode have some variable, but let us not worry about that. Then the same variable for sample is known as statistics. A different name. Parameter is for population, statistic is for sample. Okay, so this is one thing I want you to remember. And in this chapter we will only focus on this one, mean, standard deviation, median, mode. We don't focus, for us to do the thing. Alright, so based on this we are going to do chapter 5. Chapter 5, the name is estimation. So what we are going to do, what we are going to estimate is like this. In the question they are going to give you sample mean. Okay, maybe in my class the mean for the mean student, maybe the age of mean student. Okay, let's say the age of student who was learning statistics for management. Let's say X is age of student. Age of student. Now let's say I take it is given the average, the mean age of my student in my class, it is given, and standard deviation, the age of my student, is given. Okay, all these X the X bar and the S are given. If they are given, and also the number of sample size, N is number of sample size. How many people are there? N, X bar and S is given. Can you estimate the mean of population? This is the question. If you are given the sample size and the average age of student in my class and also standard deviation of the age of my student, can we estimate the mean for the whole population? Okay, the mean of student who are taking statistics in the world, statistics for management. So that's what we are going to do. So let us do number one. How to do this? I'm going to go for next page. The formula for the estimation. The formula for estimation is formula for you to do estimation. is x bar. Okay, the estimation for mean, just now I was telling that it is given the sample information n, x bar and s. We're going to estimate the mean of population, isn't it? It is not a single number. We are going to estimate in a interval. What is the number here? What is the number here? Okay, this is going to be an interval. Okay, and this interval is known as confident interval. Okay, confident interval is the range, is the interval for our estimated mean. So it's not going to be a single number, it will be between two number. Okay, approximately our mean will be between two number. So let us do one exercise. In this case we are going to do example 2. The formula for that is x bar plus minus z alpha over 2 sigma over root of n. So this is the formula for us to find the confident interval. In other words, the estimation for the mean of population. We are doing the case whereby grade n greater or equal to 30 or sigma is known. Sigma is what? Standard deviation of population. Okay, in this case we are doing this one. Look at example 2. Estimate the 95% and 99% confident interval and as associated confidence limit for the population mean when we are given the following sample data. So you are given x bar from the sample, you are given standard deviation of the sample, you are given number of sample. Okay, now let us compute. We are going to compute the interval, two number here and here. We are going to compute what is the range, what is the interval, so that our population mean will lie on the estimation from where to where. We are going to see one by one. My x bar is 950. In this case, the formula is sigma here. The formula is sigma, but sigma is standard deviation of population. If they don't give you standard deviation of population, you can replace this by S. S is what? Standard deviation of sample. So we are going to, here sigma is not given, so I'm going to replace that with standard deviation of sample. Can this is not a division, it's either sigma or s, either one. Replace either one. I hope you guys understand. Don't get confused here. Replace either one. S is 15, so let's say S is 15. I put S here. I don't want you to get confused. You can use either sigma or S. Okay. N is given 36. Alpha is actually, so first of all we're going to estimate the 95% of confidence interval first, and then we'll go for 99%. I will let you know what is this 95% after end of the question. So alpha is 1 minus 0.95, 95% of confidence interval. So 9, what do you get? 0.05 alpha over 2, 0.25. So basically what this tells is once you do this, you draw a bell shape, the 0.025 is here and here. Okay, now what would be the Z alpha over 2k is here. What is the value there? Z alpha 2 over k, which means which one is giving, go to Z table, zero point 0.025, that is 1.9 and 1.96. So this is actually 1.96. That's how you find Z alpha 2, 1.96. I repeat, how I find this value. How I find this value? If face-to-face class, I would give more explanation regarding this. Now it's online, so I need to go through according to the convenience. So I straight away teach you how to find Z alpha over 2. So for the first step, you need to find what is alpha first. Alpha is 1 minus 0.95. Why 0.95? Because the question tells you we are doing now 95% confidence interval. What is this 95%? Later at the end of the question I will interpret for you, and then find out what is alpha divided by 2. Do this one first, second do this one, third draw the diagram like this, and fourth one you do this one. Find the value. This is Z alpha over k. So just now we saw from the table it is 1.96. Now we can compute the confidence interval. This is actually confidence intervals. So let us compute now. We are going to replace inside the formula. X bar is what? 9 plus minus Z alpha 2 is 1.96. My S is 15 over root of 36. So basically, if you want to split this, how you split this? Remember, we are going to find the interval for the mean, isn't it? The estimation must come into the interval. So if you want to split this is plus minus, right here 9 plus 1.96, and write the same thing here. And if you compute, you should get this is the answer you get. You can leave the answer like this, or you can write it in bracket like this. This is the answer. So if you want to find confidence intervals, if the question asks you confidence interval, this is your confidence interval. This is your confidence interval. And if they ask for associated confidence limits, confidence limits is this one. Okay, if confidence limits, green color, each of this value. So if you want to write confidence limits, confidence limits is actually 9, 4, and you write like this. But I will ask you confidence interval only. This is just for your understanding. Confidence limit is one number and this number. Confidence interval you need to give in terms of interval. That's all. Very simple ideology. Okay. If the question asks for interval, you give in interval form. If they ask for limit form, you just write like this. Okay. Now here comes the interpretation. So what is this 95% confident interval, sir? We interpret like this. We are 95% confident that based on the sample data, the range is the interval, the range of population mean is you can leave it like this answer. We are 95% confident that based on the sample data, the range of the population mean is, so the 95% is our confident level. 5% we may wrong. Okay, 95% we believe that from the given sample data here is, okay, from the given sample data 950, 15 and 36, this is the range for the population mean. Okay, that's how you interpret the questions. Now what I want you to do now, once you guys copy this, just now we did for 95%, isn't it? We did for this. Can you guys try for 99%? Do the same method. We are going here now. 99%. Do the same method and let me know what value you get. Find what is x bar, s. The x bar, s and n are same. All you have to find is alpha over 2 and the z alpha over 2, and then replace inside the formula and get me the interval range, and maybe you can write the interpretation. Try for 99. Just now we did 95, you do 99 now. Try, I give you some time. Oh, some of you have done. Very good. So the answer is 943. Some of you have done. That is very good. Sorry, just now I mute my mic. The answer is 943.55. Some of you get 57. Okay, acceptable. And 95605. So let me do here. Let me good. Some of you have done. So 99 percentage now. Just now 95, now 99. My X bar is still 950. Somewhere 0.05. I will take this one. 0.05 is somewhere near to this, because the difference is 6 here, the difference is 8, so I go for the nearest one, 6. So here my Z is here, Z, and the value is here is 0. The value for here is 2.58. I just recall this Z is known as critical value. Critical value. So once you get all this data, now you can replace. And you replace. Let us not worry about the confidence limit. I just want the confidence interval. 2.58. Alpha is sigma is, my sigma is S now. S is my sigma. So 15 over. So I will get you will get here 94355 565. Actually, what is the value? 15 divided by 6. Yeah, 943.955. Another one is, so here you can write the explanation. Okay, this is the answer anyway. This is answer, or you can write it as 943.95643. Yeah? This is the answer. And the explanation, if the question asks, you just write the same, similar to we are 99% confident that based on the sample data, the range of population mean is okay. This is how you write your thing. Now can you guys try do example 3 for 95 and 99% before I give you the answer? Try example 3 before I give you the answer. Same method. Try to do for both 95 and 99. I'll give you the answer, both answer together. Okay, some of you get it. $62. Why 62? Cannot be 62. Are you guys sure? 62. We are doing example 3. Let me do example 3. %95. My x bar is 6.15. Average, average is the mean. Standard deviation is, my s is 1.3 and my n is 64. My alpha is 1 minus 0.95. And we have seen this is 1.96. we have done this before. And if I want to replace inside the formula, this would be 6.15 plus minus 1.96, 1.3, don't get confused with the number of see, so these are the computation. If you see, don't get confused with this is your n, this is your n, this is your mu, this is your x bar, and this is your s. So if you do this, I will give it in interval form, a bracket form. If you do this, what you get? Here you will get, I take 2 decimal places, 5.83. Here you will get 6.47. This is for 90. This is for 95. For 99, same, just alpha is 1 minus 0.99. We have seen it is 2.58, and if you do this, this one you will get 5.73, and six point 57. So this is the answer. Yeah, Umar is right. No, Shamira right. Maybe Kunis and Nur Diana, I appreciate your effort, but maybe you use mean as 64. Maybe, I don't know. Okay, maybe just rectify your mistakes. Yeah. So first identify what is your mean and all these things. This is the answer for example 3. Now I suppose after this you know what is the method, because the formula is almost the same for the next cases. Okay, so basically we are finding the estimation for the mean given the information from the sample. Okay, we are finding the estimation for population mean given the information from a sample. Now just now is n greater than 30. Now n less than 30. Okay, for n less than 30 we will use t table. I'm going for next page. In example 4 you can see n is less than 30. N less than 30 means the data is less than 30. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the previous case the data is 64, more than 30. The previous case 36, more than 30. This one is less than 30. So in this case less than 30 or either one, or sigma unknown. In our example is less than 30. So not 8, 10, sorry, 10 species. In this case less than 30 we will use t table. So the formula for t table is almost the same, lambda plus minus instead of z I am replacing t, that's all. So with this data, 10 data here, if you calculate the mean, if calculate the mean and standard deviation, mean of course is very easy to find, plus everything divide by 10, you will get 25608. Standard deviation, I'm using this formula. There are two formula, I'm using this formula. If you use this formula, you will get 28.55. Your n is of course 10. I give you some time for you to copy this, or you want to see this. I'm going very fast. The alpha (98), that would be 0.2. Since this is less than 30, we are using T table. And the degree of freedom is n minus 1. This is the formula for degree of freedom. So it's actually T 0.01 and 9. If you go here, this is the answer. For your information, this alpha over 2 is here. If you want to compare the formula, this one I write it here, and the V I write it here from the table 2.81. So now replace inside the formula. Two five three five. We got this one. Two seven. Is this what you get for the answer? Anybody? Those who have done, you can try example 5. Okay, so you get this answer. If you have done example 4, try example 5. Any problem, please let me ask me. If you cannot get, for example, 4, if you have any problem, let me know. I'll teach you. So I'm going for next page. The critical value, the T, 0.05, 11. Sorry, I forgot to do something here. The mean this is your mean, this is your standard deviation, this is your n. You can straight away do please do pass your papers. So far only 3 of you have done and check the answer with me. Don't give me last minute. If all of you give me last minute, can you imagine you in my place? So how many of you, I need to check any papers. So if you can do one by one, starting from the very beginning, it's easier for me to give my feedback. If you do this, your answer should be 262949. This should be your answer for number example 5. Yes, you are right. Haolun, P. Haolun. Those who have tried example 5 can move on to example 6. I want you to get used to it, the formula, because the process is the same process. For example 6, did you get this answer? Good. Yeah, Christopher, Noor, Diana, B. Howland. Good, you guys get this answer. If any of you trying, that is also good. Now after this, the process is almost the same. Until now we are dealing with one mean, one sample size. After this we are going to deal with two mean, two sample size, and I will give you one example for each cases. It is almost the same, formula different, that's all. You can see formula difference. All the formula is given in the final. If you have practiced yourself here and also tutorial, it is easier for you. Estimation is a easier chapter. Okay, please do past year papers. Once after this, you can, some of you already give me the answer, past year papers question for the 3 chapters. So once we finish today, hopefully next class I can finish another chapter. You can do 4 questions. Okay, another question on estimation and hypothesis testing. You can try that. Okay. Now, some of you may be still trying. I'm going to go for the next part. Confidence interval for the difference between two mean. Before I go for the difference, there's a note here you can read for yourself. If the sample size is larger means n greater or equal to 30, we use Z table. If less than 30, we use T table. Okay. Now let us consider this case. It's a Z distribution case. Z distribution means what you have to remember. I'm going to for next page. Anybody are still doing this? Okay, let me go for the next page. Okay. So Z distribution case, the only I'm really dealing with the okay, I just put Z here, Z distribution case. The consumer organization collected data on 2 types of automobile batteries. So 2 types of automobile batteries, A and B. Both population are normally distributed. So for you to use this formula here, it looks a little bit messy. Okay, after this they are more messier. Okay, but all this you can be done. Okay, when you do the tutorial and the past year papers. I'm again insisting all of you to do the past year papers. You will be happy later on. Now, for you to use this formula, which is the Z case for 2 population mean, the only condition you need is it must be normally distributed. Search for this word in the question. If it is mentioned, this phrase normally distributed, and the sample size is more than 30, then you can use this formula. I repeat, for you to use this formula, what you need to have, this word must be there, and the sample size for both population must be more than 30. Here I give the summary statistic for 40 observation for each type. So I give both A and B are 40 and 40. It need not be same. it need not be same, it must be more than 30, that's all. Alright, now both populations are normally distributed with standard deviation 1.29 and 0.88 for batteries B. The summary statistic for 40 observation of each type by average, mean, and given there. Construct 90% confidence interval for the difference between mean life hours. So what we are doing now, previously in the single mean we are finding the estimation for this, isn't it? Okay, what is the population estimation? What is the range for the population mean given the sample information? So we are finding this value and this value here. Now in two population or two sample, what we are going to find, what is the range mu1 minus mu2. So what is the value here? Something like this. Alright, now let us find all the information. Average of A is 32.25, mean B 29.81, standard deviation A 1.29, sample size for population 1 is 40, sample size for population 2 also 40, alpha 1 minus 0.9, 0.1, alpha over 2 0.05, and critical value. How to find critical value? Go here, this is 0.05, this is my critical value. Go back to Z table, .05 0.05 is either you can take this one or this one. I'm taking this one. You can also take this one, but I get used to it. I get 1.65. I write here 1.65. I write here 1.65 or 1.64. You can also take 1.64. I prefer this one. My preference. Okay, you may have your own preference. So here, why both can, because the difference for both are 5 and 5. Okay, hope you guys understand. You don't understand, please ask me. I give you some time. And I would like to do the computation here. I want to see the information. I don't want to go up and down. Give you some time to copy this and look at this, what I'm doing here. So after I get all this information, I'm going to substitute inside the formula. My x1 is minus 29.81. Okay, the plus minus I should write here, but can I write there? Do I have place? Okay, maybe I can try plus minus my critical value is 1.645. My standard deviation for first one is this, and one is 40 plus this part. Okay, can you guys compute this and let me know what is the answer?
Doctor, 1.645 or 1.65?
1.6. Okay, I'll take 1.5.
Yeah.
Yeah, sorry, 1.5.
Yeah, no problem.
Take 1.5 here. Okay, some of you get this answer. If anybody are doing, I can wait for you. So I take two decimal place, like yeah, like Howlun take 3 decimal place, Zihong take 3 decimal place. Okay, you can take 3 or 2. It's just when you take the decimal places, please round off the thing. So in my case, in my computation, whatever I did here, if I take 2 decimal place, I get 0.3, and here if I take yeah, alright, so both of you get right. You can also write like this, 2 decimal place. This is answer for Z case. If you are any of you still doing, try to get this answer. Now we are going for next. We are going for next case. Next, this is the one in 2 population. The one I covered in this syllabus for Z case. This is the only case. After this, everything, there are 4 cases. 1, 2, 3, 4. All these 4 cases, we have to use T table. Okay, T table. Next, I will go for next one. So I put here first case for T. You can see the formula is there and the degree of freedom is given there. So in this case, what is the rule, sir? When you can use this formula? See, the formula is, when you can use this formula, the condition is 2 sample size are same, 15 and 15, 2 sample size are same, and the population variation is not equal. You see this one. I repeat, when you can use T distribution case 1, 2 sample size are same, and population variance are equal. Okay, now in this case, as usual, you have to find all the information. x1 wait, in the previous case they give standard deviation. In this case they give variance, so we can write like this. Variance we can write x square. S is standard deviation, s square is the variance, so they readily give you variance is 0.3. This one is 0.44. In the previous case they give standard deviation. Where is it? Standard deviation. So we write S here. In this case they readily give you variance, so you write S square. Hope you guys understand this. N1 is 15, N2 is 15, alpha is the degree of freedom. The formula is given here, 2n minus 2, so n is 15 for both cases, right there. Once you find all the information, you replace inside the formula. Get this one? Anybody? No square on the SD. No, because the S square is 0.3. It is not S. Can you understand?
It's the variant.
Can you understand?
Yes, doctor.
Oh, okay, thank you. That's the why I stress here. This is S square itself is 0.3. It is not S. If it is S, then you square it. Can't get 0.101. Can't get. Why you cannot get? Let me double check. 0.3 plus 0.44, 0.74. Divide by 15, 0.049333. Did I do any mistake? Oh, okay, I did mistake. Sorry then. Thank you for identifying my mistake. Okay, let me redo this again. I did a mistake. Here, this one, 0.3 plus 0.44, 0.74 divided by 15. I forgot to square. Oh, this is what you asked just now, I guess. Square root. I forgot to square root it. I am very, very sorry. And if you do this, Do you guys get this now?
Yeah, I got it.
Okay, that's good. Yeah, you are right. S only is standard deviation, S square is variance. So square for the formula is mean variance. S square is a variance. Zikang. Hui Ting, did you get what I get? Is your answer same with me, Hui Ting? Hui Ting, are you there, Hui Ting? Okay, suppose you guys have to get this answer. Huh? Try. There are 3 more cases to go, 2, 3 and 4, and then after this chapter is finished. This chapter is quite easy chapter. You just have to go through certain formulas and certain condition. Otherwise the process are the same process. We will go through 3 more cases at 10:30 for one group, and another group is 1:30. So with this, that's all for today for our class. I will see you guys at 10:30 and 1:30 again. Thank you for joining my class. Stay safe and take care. Are you guys still doing, or you guys need some time? Alright, anyway, I stop the class here. I see you guys later on. Alright, bye.
Yeah, thank you, sir.
Okay.